Good day. Our lesson today is on graphs and key features of absolute value. The benchmark that we are looking at is MA 912 AR 4.4, which states that we are solving and graphing mathematical and real-world problems that are modeled with absolute value functions. Also interpret key features and determine constraints in terms of the context. So let's look at some mathematical thinking and reasoning standards. We are actively participating in effortful learning, both individually and collectively. Engaging in discussions that reflect on the mathematical thinking of self and others. Using patterns and structure to help understand and connect mathematical concepts. And assess the reasonableness of solutions. Here's our learning targets. I can use transformations to graph absolute value functions. I can determine key features of an absolute value function from a graph. So let's look at some vocab terms. The first one, the function f of x is equal to the absolute value of x, is an absolute value function. So here we have the absolute value of x is equal to negative x if x is less than 0. It's also equal to 0 if x is equal to 0. And for positive x if x is greater than 0. Students, at any time, if you wish to pause the video, please do so to help get a better understanding. So this graph of this piecewise function consists of two rays, is V-shaped, and it opens up. To the left of x equals 0, the line is y equals negative x. To the right of x equals 0, the line is y equals x. Notice that the graph is symmetric across the y-axis because for every point x comma y on the graph, the point negative x comma y is also on the graph. Here's some more vocabulary terms. The highest or lowest point on the graph of an absolute value function is called the vertex. The axis of symmetry of the graph of a function is a vertical line that divides the graph into mirror images. So let's look at this example. It's labeled for you. The blue lines here, the V-shaped, that's your absolute value function. This purple dot right in the center, that's our vertex. And the dotted line coming down, that's your axis of symmetry. Another vocab term we're going to look at, let's move this out the way. The zeros of a function f of x are the values of x that make the value of f of x equal to 0. So on this graph, f of x or y is 0 when x is negative 3 and x is positive 3. Here they are highlighted with the dots. So f of x is equal to the absolute value of x minus 3. A transformation changes a graph's size, shape, position, or orientation. A translation is a type of transformation that shifts a graph horizontally and or vertically, but does not change its size, shape, or orientation. A reflection is when a graph is flipped over a line. A graph flips vertically when -1 times f of x, and it flips horizontally when f of -1x. A dilation changes the size of a graph by stretching or compressing it. This happens when you multiply the function by a number. So here, let's look at this transformation. Here's your formula or your equation. Y, or f of x, is equal to -a times the absolute value of x minus h plus k. Remember that h comma k is your vertex. So let's identify each piece of this equation. So here your arrow is pointing to the -a. This is where it's the reflection across the x-axis. This is where we see if there's a vertical stretch, that means a is greater than 1, which makes it narrower. Or a vertical compression, where a is greater than 0 but less than 1, which makes it wider. The h, it's the horizontal translation. So that usually is the opposite of h. So in this here, it says a minus h. So the opposite would be positive h. And then your k is your vertical translation. So where you see the h and the k, that's your vertex. So opposite h, comma k would be your vertex. Let's look at an example. Here's example 1. Let's identify the transformations. And my equation says y is equal to 3 times the absolute value of x plus 2 minus 3. So the first thing we need to identify, the parent function. My parent function, let's grab the pen here. My parent function for this absolute value, that would be y equals the absolute value of x. That's our parent function. So from our parent function, which is from the vertex, which is right in the center of our graph, we have a horizontal shift where this is telling us it's left 2 units from the center. And then the -3 here, which is our k, that's our vertical shift. From the 2 units left, we go down 3 units. This point gives us our vertex. Okay, hold on 1 second. Let me try to erase this. Right. Let's grab the pen again. Let's try writing that word again, vertex. Okay, so that's our vertex. Now, is there a reflection about the x-axis? No, there isn't. There's no reflection about the x-axis, but it does have a vertical stretch. Over here, you can see that the domain of the expression is all real numbers, except where the expression is undefined. But in this case, there is no real number that makes the expression undefined. So here, the set builder notation, it tells you that x, such that x has all real numbers. So any number can be replaced for x in this equation. Your interval notation, it's telling us negative infinity, comma, positive infinity. Negative infinity to positive infinity. We also have some to graph this absolute value function. We're using the vertex and a few selected points. So as here circled here, this is our vertex. And then we went and found our x-intercepts. So here you can see on the table of values, one of my x-intercept, it's -3, 0. And the other one is -1, 0, which are plotted here on the graph. And we also have our y-intercept. So this one is our y-intercept, 0, 3 on the graph. Here's my y-intercept. And this is my x-intercept. This one is also my x-intercept. And those are plotted on the graph, on the x-axis. The y-intercept is plotted on the graph as well, on the y-axis. And then we found another point, -4, 3. We place -4 in for x. Add that to the 2. That gives us -2. And the absolute value of -2 is +2. 2 times 3 gives us 6. And then we subtract that 6 from the 3, which gives us a +3. So another point on this graph is -4, 3, which is right here. Another key feature for this example, we have our range where y is greater than or equal to -3. Y is greater than or equal to -3. So we end up graphing the equation to determine the intervals over which it is increasing or decreasing. It's increasing on -2 to +infinity. And is decreasing from -infinity to -2. Okay, so let's look at another example. Here we have y equals -1/3 times the absolute value of x minus 2 plus 1. Here we have a table of values as well. And we have here our x-intercept, -1, 0, which is labeled right here. And then our y-intercept is at 0, 1/3, which is right here on the graph, on the y-axis on the graph. Other points were plotted. We have 2, 1, which is here. And then we have 1, 2/3, which is here. To find that x-intercept, we substituted 0 in for y. So we made y 0. And then we solved for x, which we got -1, 0. To find the y-intercept, we substitute 0 in for x and solve for y, which is what we have here, 0, 1/3. Once again, our parent function, it's y equals grab the pen again. So our parent function it's y equals the absolute value of x. So that would be right in the center of this graph. Right here in the center, your vertex would be 0, 0. And it will have a ray on the left and a ray on the right. This equation has a horizontal shift where we are moving 2 units to the right. So remember, that's the h right here where we have -2. This is our h. Opposite of h would be +2. So 2 units to the right. And then a vertical shift, we're going 1 unit up. So from the center, 2 units to the right, 1 unit up. This right here is our vertex. Sorry about that. Let's see if we can do that a little better. There we go. That's our vertex, 2, 1. or it's our HK, opposite of H, and then our K. Our domain it is from negative infinity, comma, positive infinity. Where we have x such that x is all real numbers. That's our domain. Our range, and right now we're looking at our key features. Sorry about that. Let's fix that there. So our range is where we have negative infinity to positive 1, where 1 is included. So it is y, sorry about that again. Okay, where we have y such that y is less than or equal to positive 1. This one has a vertical compression. Because of our negative fraction here. Negative fraction. And that's pretty much all we can look at for this example. The last example we're going to look at today, here is asking us to graph y equals negative 2 times the absolute value of x plus 3 plus 2. So, what is the vertex? Remember, to find the vertex, we look at our h. Opposite of h, so it's h comma k. And our vertex would be negative 3 comma positive 2. Remember, this right here is our h. So the opposite of h, and this is our k. Whatever k is, that's what we use. So the vertex in this case is negative 3 comma 2. Let's move this out the way. So that point would be here. Let's start from the center and go 3 to the left. 1, 2, 3. Don't place your point here because we have to go up 2. This right here would be our vertex. Right at this point. This right here is our vertex. So to find other points, let's find our y-intercept. So we're going to let x equal 0, because this is going to ask us what are our intercepts. So let me move that out of the way. Erase this out of the way. And we will replace it where that vertex is. This is -3, 2. So our x-intercepts. So let's first let x equal 0. And then solve for y. So taking our equation, y equals -2 times the absolute value of 0 plus 3 plus the 2. So let's start right here in the center, in the middle of the absolute value. 0 plus 3 gives us 3. So we still have our -2 on the outside. And then we're taking the absolute value of 3, which is just simply 3. So this becomes -2 times 3. And then we're adding 2 to it. So this will give us -6 plus 2, which is -4. So our y-intercept would be 0, -4. This is our y-intercept. So we place that on the graph, which is on the y-axis. Let's move that word vertex out of the way. So 0, 4 would be right here. So far we have 2 points. I'm sorry, it's 0, -4. That's my mistake. 0, -4. It would be down at the bottom. 0, -4 here. So that's our y-intercept. Now to find our x-intercept, we're going to let y be 0 and solve for x. So when doing the absolute value and solving for the absolute value, we end up with 2 values for x. So this is what I mean. We let y be 0. Okay, so we're going to move this out of the way. Okay, so we found what our y-intercept is. And we're going to place that here. Y-intercept. We said it was 0, -4. Now to find the x-intercepts, we're going to let y be 0. So using that same equation, So instead of y, we're going to put 0 equals -2 times the absolute value of x plus 3 plus 2. Now we need to solve for x. So to do so, we have to start outside here, do the opposite to this positive 2. We subtract 2 on both sides. This will cancel here. On the left side, 0 minus 2, that gives us -2, equals -2 times the absolute value of x plus 3. So now at this point, I have to divide both sides to get rid of this -2. Opposite of multiplication is division. So divide by -2 here, and on the other side of the equal sign, also divide by -2. -2 divided by -2 is +1 equals, this is a 1 here. Normally you don't see it. So we just leave that blank and just rewrite the absolute value of x plus 3. So now to get rid of those absolute value signs, we end up with 2 equations. We have 1 equals absolute value of x plus 3 let's get rid of the absolute value signs when we're writing our equations. Okay, so one example would be 1 equals x plus 3, and the other equation, not example, equation, it would be -1 equals x plus 3. Because remember, we have 2 rays, one on the left side, on the negative side, and one on the right side, the positive side. So let's solve the first equation. We -3 here and also on the other side. So -2 is equal to x. So that x-intercept is -2, 0. And then this example on the right side, subtract 3. So we're going to subtract 3. Only if this thing will start working properly. Okay, let's try that again. We're going to subtract 3. And do that to both sides. This cancels here. And we have -4 is equal to x. So the other x-intercept is -4, 0. So we're going to plot those two x-intercepts. So -2, 0 is here. And then -4, 0, it's here. So we can see where the graph is going and just connect those points as best as you can. And that's graphing y equals -2 times the absolute value of x plus 3 plus 2. Thank you for listening and have a great day.